Hi, this is Mrs. LaBarbera. This is Physics Chapter 10, Waves Intro, Video 4. Today's topic is categories of waves. The objectives are: know the definition of transverse, longitudinal, electromagnetic, and mechanical waves. Be able to give examples of mechanical wave, electromagnetic wave, transverse wave, and longitudinal wave. Transverse wave versus longitudinal wave. A transverse wave is produced when particles of the medium moves perpendicular to the wave's direction of travel. As you can see, the direction of wave is from left to right, but local particles going up and down because the source is moving up and down. And here's a little thing tied on the slinky. It goes up and down. Okay, this is an example of a transverse wave. Longitudinal wave is particles of the medium moves parallel to wave's direction of travel. The hand moves parallel to the direction of the travel, left to right, and so is the particle moves left to right. Take a look at this local particle right over here. It moves left to right. That's a local particle moving. Examples of longitudinal wave and transverse wave. So transverse wave, we saw wave on the string. We saw wave on the slinky. We know stadium wave is transverse wave. Also another wave we're going to learn a lot more is light wave. Light wave is transverse wave. You have to remember that. Longitudinal wave, another thing you need to remember is the sound wave. So we're going to study sound a little more next chapter. So sound wave is a longitudinal wave. It's also called a pressure wave. Wave on a slinky can be longitudinal or transverse. Also, you probably learned P wave, the earthquake P wave. That's also longitudinal wave. So one thing you need to know, kind of be familiar with now, is transverse wave travels faster in sparse medium, like transverse wave. Light travels fastest in vacuum, while longitudinal wave is mechanical wave. It travels faster in denser medium. The other category is electromagnetic versus mechanical. So another way to categorize wave is on the basis of their ability to transmit energy through a vacuum. An electromagnetic wave, such as light wave, is produced by vibrating charged particles, such as electrons. Is a wave which is capable of transmitting its energy through vacuum. So light wave is electromagnetic wave. A mechanical wave, such as a sound wave, is a wave which is not capable of transmitting its energy through a vacuum. Mechanical wave requires a medium in order to transport their energy from one location to another. Like sound wave, sound wave cannot be transmitted in vacuum at all. A sound wave is an example of a mechanical wave and longitudinal wave. So sound waves are incapable of traveling through vacuum. On the other hand, light waves are examples of electromagnetic and transverse waves. So light wave can travel through vacuum. A summary of categories of wave. So wave can be categorized by the vibrating direction. A transverse wave is perpendicular, right? Local particles vibrate perpendicular to waves motion. Longitudinal wave is local particles travels parallel to waves motion. And we can also categorize waves by medium. So energy can be transmitted in vacuum. That's called the electromagnetic wave. And energy cannot be transmitted through vacuum, called a mechanical wave. So there are other categories as well. These two categories you definitely need to know. Okay, so you also need to know light wave. Light wave is electromagnetic and transverse. And sound wave, on the other hand, is mechanical and longitudinal. So those are two special waves we're going to study in detail. Let's take a look at a couple of examples. The student plucks a guitar string and a vibration produces a sound wave with a frequency of 650 Hertz. So the sound wave produced can best be described as, is that a sound wave a transverse wave of constant amplitude? Is it longitudinal wave with constant frequency? Is it a mechanical wave of varying frequency? Or is it an electromagnetic wave of varying wavelength? So we've learned sound wave is mechanical and longitudinal, so it can only be two of three. The other one is the frequency constant or is it varying? We said the frequency is 650 Hertz. 650 is a constant, so the answer is 2. Another example, an electric bell connected to a battery is sealed inside a large jar. What happens as air is removed from the jar? Let's see, electric circuit stops working, or the bell's pitch decrease. The bell loudness increase because of a decreased air resistance, or the bell's loudness decrease because sound wave cannot travel through vacuum. Let's see, what is a sound wave? Sound wave is mechanical wave, which needs a medium to travel. So the sound needs air to travel. If you remove the air, the sound is not going to travel. So loudness actually decreases because sound wave cannot travel through a vacuum. It is a mechanical wave. Last question says, which pair of terms best describe light wave traveling from sun to earth? We know light is electromagnetic and transverse, so that's the answer. That's it for today. Thanks for watching. See you next time.